Hello, my name is Dr. Steele, and welcome to Steele Mathematics, where lessons in Algebra 1, Geometry, Algebra 2, Pre-Calculus, and Calculus are taught. And today, we're going to be talking about factoring quadratics or factoring trinomials. Now, what does it mean to factor trinomials? Well, it means to rewrite it such that it is a product of two binomials. So with that being said, I'm going to show you how you can do just that. To factor ax squared plus bx plus c, we must first factor ax squared. So when you factor ax squared, you can write it as jx times kx. Next, you're going to draw a big X. Now, in the top section of that big X, it's going to be the product of the leading coefficient and the constant. And in the bottom portion will be the coefficient of your middle term, which is also called your linear term. Next, you'll find two numbers to where their product is AC and their sum is B. In other words, the product is the product of the leading coefficient and the constant, and their sum is the coefficient of the middle term. Finally, you're going to divide the two numbers by the coefficients of the leading coefficients of the binomials. You're going to divide n1 by k and n2 by j. And when you do that, that will be your solution. The two binomials that you multiply to get that quadratic or that trinomial. So let's look at some examples. Let's say you are factoring 3x squared plus 11x plus 6. All right, the first thing you're going to do is you're going to factor 3x squared. That's 3x times x. Next, you're going to draw your big X. On the top portion is 3 times 6, which is 18. And on the bottom portion, it is 11. So now what you're going to do is you're going to look for two numbers that you multiply to get 18 and add to get 11. And those two numbers are 2 and 9. 2 times 9 is 18, and 2 plus 9 is 11. So now what you're going to do is you're going to take one of these two numbers and divide by 3, and you'll divide the other by 1. Well, 3 can go into 9, so 9 divided by 3 is 3. Now notice, I did not put that 3 in the same group as your divisor. Never put your quotient in the same group as your divisor. And 2 divided by 1 is 2. Therefore, your solution is 3x plus 2 times x plus 3. Next, we're going to factor 6x squared minus 5x minus 4. So what you're going to do is you're going to factor 6x squared, and we're going to try 6x and x. Draw your big X. Multiply 6 times -4. That gives you -24. And the bottom portion, you put in -5. Now, you're going to look for two numbers that you multiply to get -24 and add to get -5. And those two numbers are -8 and 3. So now that we get our two numbers, you're going to divide one of them by 6 and the others by 1. But guess what? 6 can go into neither -8 or 3. When that happens, that means you are going to have to refactor 6x squared. So we'll try 3x and 2x. 3x times 2x is 6x squared. So now you're going to, those two numbers we found, the -8 and the 3, you're going to divide one of them by 3 and the other by 2. Well, 3 can go into 3. Therefore, 3 divided by 3 is 1. Remember, do not write the same quotient. Do not write the quotient in the same group as your divisor. And -8 divided by 2 is -4. And therefore, your solution is 3x minus 4 times 2x plus 1. Next, we have x squared minus 7x plus 12. Well, we know x squared is x times x. We're going to draw your big X. 1 times 12 is 12. -7 in the bottom portion. Now we're going to look for two numbers where you multiply to get positive 12 and add to get -7. And those two numbers are -3 and -4, because -3 times -4 is positive 12, and -3 plus -4 is -7. And you're going to end up dividing both of those numbers by 1. So you might as well just go ahead and put them in. And therefore, your solution is x minus 3 times x minus 4. So factoring trinomials or factoring quadratics basically takes knowing your timetables. It takes knowing your timetables when you factor your leading term, and it takes knowing your timetables to find out what two numbers you multiply to get the product of your leading coefficient and your constant, and add to get the coefficient of the middle term. I hope that you have a wonderful and blessed day.